Hello everyone, I'm Lalit Singh. Welcome back in Android Developers Fundamental course. We're gonna start with lesson 7 background task. Now, we have a good idea about user control, UI design, how we can transfer between different activities. Now we're gonna learn more about background tasks. What do I mean by background tasks? Long running processes, which takes too much, which takes too long to run, and it can crash your application, it can crash your activity. So how exactly we can deal with those kind of tasks? So the answer here is async tasks, and we're going to learn about async tasks loader also. So in this particular session we're going to learn about what are threads, what are async tasks, how exactly async tasks help us to deal with those kind of problem which we face in our Android application development, how loaders are better than async tasks, and what is async task loader. Let's just talk about threads first. So what are threads? Well, thread is a single unit which is doing a particular task. It can be a part of a complete process. A process will at least contain one thread in it. A process can contain more than one thread. For example, let's say your teacher gives you to check 50 papers. Now the process here is to check the 50 papers, and the thread which is working on it right now is only you. Now let's say you involve your 5 friends too, and you give 10 papers to each one of them. Now what is happening? Still a single process, but this time the threads, how many threads are running? 5 threads are running simultaneously. So thread can drastically change the efficiency of your program. It can increase the speed of your program, or it can increase the speed of your application in which it is running. Now, when we talk about Android application development, Android application runs on a main thread, also known as UI thread. What exactly main thread does? All the fundamental components like activity, services, broadcast receiver, content provider, they all run in the main thread, except what happens? Activity, services, broadcast receiver, they run in a synchronous way, but content provider is the only one which can run directly in a asynchronous way in the main thread. So what do I mean by synchronous way? Now let's say I have an activity. In that activity, I have a edit text at the top, then I have a button, and then I have a list view. Now, as soon as I'm not halting my main thread for too long, that how much that too long is? Well, it's not more than 16 millisecond. If you are halting your main thread more than 16 millisecond drawing any UI component, your main thread will crash, or your application will generate ANR. What is ANR? ANR is known as application not responding, and you do not want to generate that whenever you are dealing with your Android application development, because it's a bad user experience, and user don't really want to open up or install that kind of application which generates ANR. So how exactly a main thread should work like, or how exactly a main thread works? Well, your application comes into the main thread, it gets updated. If your UI is not taking too long to update, if it's just a edit text, if it's just a button to draw, your UI is smooth. Now let's say that list view, you still have a list view to draw. Now that let's say that list view is getting or fetching the data over the network, from the network. Now what happens at this point of time? Well, you don't really know how much time it's going to take to fetch the data from the network. So it might hold, or it might slow your process of drawing your list. So in this way, at this point of time, if your list takes too much time, that is, your UI thread has only 16 milliseconds to do all its work. Now, so if it takes more than that, your app might generate an ANR, and that's what you don't want. What exactly ANR looks like? This is the ANR. You must have came across this dialog box, your application not responding, and it asks you, do you really want to wait for it, or okay, you press OK and your whole application finishes off. So your Android framework gives you this ANR whenever it sees that there is a problem, or your main UI thread is being halted by any one of the UI or view you want to design in your activity. So what are long running processes? Well, all the network operations, big calculations, downloading files, uploading files, loading data from the database or processing images, they all consider into be a long running process. Now, you do not want to put all these processes directly on your main thread. So you do not want to put the code of fetching the data from the internet inside your main thread, or you don't want to fetch the database, especially if it is a large database, millions of database you have to search out, and it can take time. At that point of time, you really don't want to put that code inside your main thread. So what's the way? What's the way to get around with this? Well, the way to deal with this kind of problem is you have to use a worker thread. Now, what is a worker thread? Now, let's just take the same example which I've been taking. I have edit text, I have a button, and I have a list. Now, that list is fetching the data over the network. Now, there will be no problem in designing your edit text. There will be no problem in designing your button. Now, when it comes to list, now list might take some time. So what I do, I know that I cannot put directly my list on my UI thread. So what I do, I create a background thread known as worker thread. I do the functionality part inside that worker thread. Now, please be apprised that inside your worker thread, you cannot update your UI. You will not populate the list inside your worker thread. All you will be doing inside your worker thread is the functionality. All you will be doing inside your worker thread will be the functionality to fetch the data. Once you get the data, you will again go back to your UI thread and then update it. So that's how a worker thread works. So what are the different classes which you can use with respect to this worker thread framework? Well, your async task is the first example. Your async task actually works with this concept only. There is a worker thread running in the background, and as soon as it sees there is a long running task, it passes that control to the worker thread, and worker thread does it in the background, and it comes back to your main thread and it updates it. In the same way, loader framework also works, and in the same way, services also works. We'll talk about services in our coming session, but just know that every time you see there is a long running process and it is being carried out, it is not being carried out in the main thread, but it is being carried out in the background thread. That thread is known as worker thread, to provide the smooth updation of your application. Well, there are two rules which you should take care whenever you are designing your Android application. First, do not block your UI thread. Well, what do I mean by that? In any circumstances, if you think that there is a view, there is anything which is going to take too long to process, then do not put that code inside your UI thread or main thread. Always create a background thread and put that functionality in there. What is the second rule? The second rule is do not access your Android UI toolkit outside from UI thread. Again, what do I mean by that? Well, I know I have created a background or worker thread in the background. Now, do not call text views or progress bars or any view to be updated inside that worker thread. Always go back to your main thread and update them there. Okay, so that's what that second point means, that you cannot call an Android UI toolkit outside from your main thread. Ultimately, the updation to a UI will be done in your main thread. It's just that you cannot hold your main thread more than 16 milliseconds. So if there is any task which is taking long, put in the worker thread, put the functionality, come back to your UI thread, update it. If you think, okay, you still need more data, again go back to your worker thread. As soon as the data is coming, you keep on populating to your UI thread, and your worker thread is working in the background. Once the work is done, it will come back to your main thread again by finishing up the work. Now, let's just talk about the async task. Now I know how I can deal with the long running processes. I can always create a background thread and put the functionality there. So what exactly is the structure of this async task? Well, the best thing about the reason we have created a async task classes, it provides you a very good framework to put your data in your worker thread, that is a background thread, and then update your UI very smoothly, very smoothly and very efficiently. How come? Again, you will be creating your application will be running in the main thread, and you will be creating a async task class. Inside that async task class, there is a abstract method known as do in background, and that do in background is running in your worker thread or background thread. Once that method is done, this is where you put the functionality. Once your method is done or once your task is done, it will again come back to your main thread with the help of a method name on post execute. We'll talk about these methods in a bit as we move on. Just know for now that there is a main thread, the worker thread inside the async task will be executed in a method named as do in background, and it will come back to your UI thread by the method name on post execute. Okay, so when we are creating any async task class, we need to take care of some methods. That is, we need to override some method. What are those methods? Well, first, do in background. This is the abstract method inside your async task class and which runs in the worker thread. So you cannot update any UI operation here. So how will I update my UI operation? Let's say you want to update any UI at the end of the functionality of your task. Let's say once your task is complete, now you want to update your UI, any text view or any edit text. Then you will be using on post execute. You have to override this method, and this method also runs in your main thread, main UI thread. It helps your it helps your data, which is in your do in background, to to bring it in your main thread for the updation. Now there are other methods also which you can use. For example, on pre-execute. Well, when we are talking about on pre-execute, if let's say you want to show any UI or any view before you actually get into your do in background method, before you actually start your long running process, that's when you want to override a method name on pre-execute. Now what happens if you want to update your UI while you are running your background process, while you are running your process? At the same time, you want to update your UI. For example, if I have to take an example, you must have seen downloading a file. Now, whenever you are downloading file, at the same time, your progress bar also gets updated. So how exactly they do it? Well, of course, I cannot put any UI operation inside my worker thread. So what exactly they do? They call a method named on progress update. Now, on progress update can be called from within the do in background by a method name as on publish progress. So we will see a complete block diagram here. As you can see, there will be a main UI thread which will be responsible for updating all the UI operations. So if you want to perform any UI operation before you actually execute your worker thread or do in background method inside your async task, you will put inside your on pre-execute, which will run in your main thread. That's the reason you can put the UI operations there. Then once you come into the worker thread, then you cannot put directly any UI operation in the worker thread. But at the middle of the progress, if you want to update something, whatever you got, whatever the progress you have made, and you want to update that same progress back to your UI thread, then you can call a method named publish progress. Now, once you call this publish progress, it will automatically start searching for on progress update method inside your async task class, and on progress update runs in your main UI thread. So here you can now update your UI operations or your views. Next, now let's say you want to update at the last, once your functionality is finished, once whatever you were doing in your worker thread or doing background, after that you want to update, then you can use on post execute. This will be this also runs in your main UI thread. Now, let's just see how exactly we can create a async task. Like I said, you can create any class. Now, if you think that your async task class is a generalized class which can be used from other activities also, then create a separate async task class. And if you think your async task class is only will be only used by this particular activity or a particular activity, then create it as a private class. Create class or any class name extends async task class, then we have three parameters there. What are those three parameters? First is known as param, second is known as progress, third is known as result. So while you are creating any async task class, you have to take care of these three parameters. First, param. Param means what is the parameter you want to pass while you are executing your async task class. This is very helpful. Let's say you want to connect to a website or you want to connect to a server. At this point of time, you'll be passing a URL of that particular website or server. Let's say you want to execute any database operations. So at that point of time, you will be passing a query here. So the param will change according to your requirement, the data type. Generally, it will be string. Second, that is progress. What is the progress you want to update along the way? Let's say you are downloading a file. Along the way, you want to update the progress bar too. So now this progress will be in integer. The progress will be generally in integer, but it can be in any other data type also. You must have seen while you are downloading software or a game, you must have seen at the below, it tells you about what is the file name which have been downloaded right now and what is the next file. So it's depend upon you what kind of data type you want as progress. Generally, it will be a integer to update the progress bar, but it totally depends upon the user. Last is result. What kind of result you are thinking that you will get out of this async task class? What is the purpose of creating that async task class? Let's say you want to download a file from the internet. Now that this result will be according to that file. Let's say it's an image file, it will be bitmap. If it's just a text file, it will be string. Or let's say you are creating an async task class to connect to the database. Now at that point of time, result will be cursor. So according to the requirement of the user, async task class is highly customizable. Okay, as you can see, the definition of the class here, and there are three parameters: string, integer, and bitmaps. Now, the string parameter will be taken by your do in background. Now, whatever the parameter you are passing here, whatever the type of parameter you are passing here, it will be the same in your do in background while you are overriding it. And whatever the parameter type of parameter you are passing as progress, it will be the same as you will be overriding on progress update. So in on progress update, you will be getting the parameters as integer only, and on post execute you will get the parameter whatever the result you are getting. So this is how you override a on pre execute method. It's just protected void on pre-execute, and if you want to show any, let's say, progress bar, you will put the code of progress bar, progress dialog bar. If you want to put a toast or any other UI operation, you can put it here. Now this is how your do in background signature looks like. Now as you can see, protected bitmap. Now the return type of your do in background will be always the same as your result parameter. If your result parameter is a bitmap, it will be a bitmap. If it is string, it will be string. If it is integer, it will be integer. Now in this particular example, you can see that I wanted to download a image, so it will be bitmap. Now the parameter, the argument inside your do in background is a string array, or you can say var concept of Java. So it's a string array which is similar to whatever the parameter you have passed in your async task while you were declaring your async task. The very first thing, that is string. If you have passed it string, it will be string. If there is any other data type, it will be any other data type then. So now why exactly it's an array of string, or why exactly they have used var concept of Java? To do your multi-threading. If there is just one URL, you can just access a URL, one URL which will be placed at your 0th position. If there are more than one URL, you can always go through them with for each loop. And at the end, you have to return a bitmap. Once your whole task is done, ultimately the result should be an image. So you return that bitmap image. Now let's say at any point of time you want to update a UI like a progress bar or something. At that point of time, you need to call on progress update. On progress update, uh, signature looks like this. Inside your on progress update, the argument which you will be using is integer var. Now it's the same which you have passed in your async task class as progress data type again. So it's again a var because there might be a chance you are doing multi-threading. And here you can perform your UI operation. Let's say you want to update a progress bar. You can set up progress, set progress, or set progress percentage, and progress 0th position if there is only one. If there is more than one progress bar to be updated, accordingly they will be placed at their own positions, starting from 0, 1, 2, 3. At the end, on post execute. On post execute method is overrided whenever you want to update any UI after you are done with your async task. And you can see in the parameter, it's the same result type which you have passed. It's a bitmap only, which you given at the very starting itself. Now, let's see how exactly you can execute. I mean, my async task class is ready. In my async task class, all I have to do is create a class and I override a bunch of methods, and my async task class is ready. But how exactly I execute it in a activity, or how exactly I trigger that? Well, to trigger that, first thing first, that you need a object of that async task class that I can get very easily new my async task. And if you are passing any argument at that point of time, you pass the argument dot execute. Dot execute is the method which will allow you to execute your async task class. Now, whenever it sees dot execute, it will go to your async task class and it will start the life cycle. Like, it won't directly go to your on do in background method. First, it will execute on pre-execute if there is any. There is not, it will directly execute your do in background. At the end, it will execute on post execute if there is any. Now, you could have passed the parameters directly in your execute also. Directly, if you want to pass a URL, you could have passed execute, then pass the URL and close. So, or that's first URL, then put a comma, another URL. So that would help you in multi-threading. Okay, now let's just talk about limitations of async task class. We have seen how magnificent async task class is. We know that whenever we change the configuration of our device from portrait to landscape mode, our activity gets destroyed. It gets recreated. So due to that, if your async task class is running for portrait mode, now if you have changed your configuration, your async task class is no more. You whatever the changes, whatever the progress which was already done in portrait mode, you won't be able to retain it in your landscape mode. So you might have to create a new async task class, or you might want to put a code which will retain that previous async task class. So when exactly you want to use async task class? Well, for all your short and interruptible tasks, and whenever you do not often want to report back to your UI thread, and for all your low priority tasks. If you think that your task has a high priority and it might run for too long and you want to update your UI very oftenly, then I would suggest you start using your async task loaders. So before we get into async task loaders, let's just talk about what exactly are loaders. Well, we know what were the challenges which we were facing in async task class, that whenever we change our configuration, our data goes away. Whatever the progress we have done up until now, it's gone. So loaders are designed by keeping that in mind. Of course, they will be loading our data asynchronously only. They will be inside a worker thread working inside your loaders only, inside your loaders. So there will be a async task class and a worker thread working inside your loader also. But what is the special property of loaders is, even if you change your configuration, your data doesn't go away. It retains. Whatever the progress you have done in portrait mode, it will still remain in your landscape mode also. The second thing is, if you want to update your UI oftenly, as soon as the data gets changed, you want to update your UI, at that point of time, you can use loaders also. Loaders are the best way to update your UI at a regular interval of time. You do not want to use async task class for updating UI on a regular basis. Loaders are the best way to do that. Again, why we want to use your loaders? Of course, any task you want to put off your UI thread, any long running process you want to put off your UI thread, you will be using loaders for that. And any task you think you want to handle even when you change your configuration, you don't want to get that data, you don't want to lose that data, again you will be using your loaders for that. And you don't have to wait for your data to load, your UI to update. As soon as it gets the data, your UI or your view gets updated. So what is a loader manager? Well, loader manager is a class which manages all your loaders inside the activity. So there may be more than one loader you are using inside one activity. There may be a cursor loader, there may be async task loader, there may be a customized loader of your own also. So if you want to handle all those loaders, you will be using loader manager class to handle, because loader manager class provides you the callback methods for your loaders, like when exactly your loader class will start, what happens when it finished, right? So all these methods is being provided to you by your loader manager class. So how do you actually start your loader, or how do you actually get a loader object? For that, we have a method known as getLoaderManager.initLoader. Now, initLoader initializes your loader manager class object. Once you get the loader manager class object, now your callback methods will start calling up. The very first will be called as the create, by creating on create loader. We will see that in further slides. But yeah, your loader gets initialized as soon as it sees that init loader method has been called. So how exactly I can implement the async task loader then? So let's just see. Now we know what exactly a loader is. It will help you even retain your data in the configuration change, and you can update it, update your UI on regular basis. You don't have to wait for it. Now, how exactly we can implement an async task loader then? First of all, understand the architecture. Async task loader, under the hood, there is an async task, and inside that async task, there is a worker thread, that is a work to do. What happens is, now your activity, instead of directly contacting to your async task, it will contact to loader manager, and loader manager in turn contact to the specific loader. Now, if there is another loader or multiple loaders, loader manager will be the one who is responsible for contacting other loaders. Your activity will always contact to just loader manager class. So you see, under the hood, it's still the async task. It's just that they have provided another class which will which is actually doing all the configuration change coding and regular UI updation coding for you. So what are the changes here? From async task to async task loader, what are the major changes you have to take care is, in async task class, you were using do in background method. Here you will be using load in background. There you were using, after your task was done, you were updating UI in on post execute. Now here you will be updating your UI in on load finish. Once your task is finished, once your async task loader is finished, it will always call on load finished. How do you create a async task loader class? Again, create any class, my own loader, extend it with the class name async task class loader. Implement the constructor there, and implement the or override the methods like load in background, on start loading, what happens whenever your loader gets created, and other callback methods of loaders. So that's how you can create a async task class loader. Just call it, just name it whatever the name you want to give, and then extend the async task loader and provide the type of data you want to process here. Maybe a list, maybe any other data structure you want to process. Then in your constructor, you will be passing, if you are using it outside the class as a generalized, you might need context object and whatever the data other data you want to pass here. The main thing which you need to take care here is the load in background method, which you are going to override, will return the same type as you have defined inside your while you were defining your async task class loader. Like you defined here list, so your do in background will return a list only. So it's kind of a result parameter here. So whatever the result you want, you put it in the starting itself, and do in background or load in background method will return the same data type. And inside this, you will put all the functionality what you want to do, what you want your async tasks class loader to do. On start loading method is executed whenever init loader, your loader gets initialized for the very first time, or whenever a restart loader method is being called. Init loader will be called for the very first time whenever you are initializing your loader object. Restart loader whenever your loader gets finished, and or whenever you are restarting your loader after your loader has been finished, and you want to restart your loader again your on start loading method will be called. Now let's just talk about some callback methods which you need to implement inside your activity to handle your loader. What are those callbacks method? First, on create loader. It creates and returns a new loader ID to you. Every time you want to create or you want to call a loader, the first callback method which is being called by your loader is your on create loader. It gives you the access or the object of the loader itself. On load finish, when the previous created loader has finished loading. So whatever the task which was being done by your previous loader is finished, then this on load finish will be called. It's just like your on post execute. Then on loader reset. Now this method will be called whenever your previously created loader is being reset. So this is how you can define an on create loader. It will return you the loader object itself, and it will take the parameters of ID and a bundle argument. And this bundle argument is necessary. Let's say you change the configuration now and you want to retain those previous values, you can get it from your bundle arguments now. And you have to return an object of the loader which you want to initialize here. Like in our case, it was the string list loader, so I will initialize that. Let's say your result is finished in your load in background method. Now your data will be passed back to your on load finish method, just like on post execute, and you can update the UI here. You can update the list, you can update the recycler view or grid view, whatever the data you have gained back from your load in background, you can update that data here. Your on loader reset will be called only when your loader has finished or destroyed, and you want to reset your loader, and you want to reset all the data of your loader. So at this point in time, whatever the data your loader has already updated or processed, it all will be nullified. It all will be started from square one. Again, how we can get the loader object? That is init loader loader method. Now, if you want to support more of the devices, if you want to support your loader in more of the devices, then instead of directly getting init loader from loader manager, you get the object of init loader from get support loader manager. It is getting the loader manager object from the support libraries now, and we all know what support library does. To learn more about your async tasks and async task loaders and loader managers, please follow the following links. Next, we are going to see the concept and the practical in the Git book. And we are also going to see a small demo on async task class. Thank you.